Writing a system of equations in context. In this lesson, we're going to look at word problems, and we're going to see how we can use the information in the problem to write a system of equations that represents the scenario. Let's start by looking at an example. A school is organizing a cookout where hot dogs will be served. The hot dogs come in small packs and large packs. Each small pack has 10 hot dogs, and each large pack has 18 hot dogs. The school bought 6 packs of hot dogs that have a total of 76 hot dogs. Write a system of equations that could be used to determine the number of small packs purchased and the number of large packs purchased. Define the variables that you use to write your system. When modeling with a system of equations, the first thing that we want to do is we want to define the variables that we're going to use. The variables represent the quantities that you're trying to define. Look in the word problem for the thing you are trying to determine. Here, we want to determine the number of small packs purchased and the number of large packs purchased. These things that we are trying to determine are what our variables will represent: the number of large packs purchased and the number of small packs purchased. Now we assign a variable to each of them. You can use any letter that you choose. I like to use letters that make sense. For example, for the number of large packs, I'll use the variable L, L for large. For the number of small packs, I'll use the variable S. But of course, you could simply use X and Y or any other letters that you choose. Now we have to begin looking at the problem and putting the pieces of information together in order to write our equations. The first thing that I see is that the school bought 6 packs of hot dogs. They bought a total of 6 packs. That means the number of large packs plus the number of small packs is equal to 6. How many large packs did we buy? Well, according to the let statement, L is the number of large packs purchased. So I have L. Next, we bought small packs. How many small packs did we buy? According to the let statement, we bought S small packs, so I'll use the variable S. The number of large packs plus the number of small packs equals 6. So the first equation is L plus S equals 6. Now we have to write our second equation. We see in the problem that we have a total of 76 hot dogs. That's what we will use to write our next equation. Now, how do we put these pieces together? Well, each small pack has 10 hot dogs, and each large pack has 18 hot dogs. There are 18 hot dogs in a large pack, so 18 times however many large packs I have give me the number of hot dogs from large packs. There are 6 hot dogs in each small pack, so 6 times the number of small packs will give me the number of hot dogs from the small packs, and that total will be 76. I now have my system of equations, which I could solve in order to determine the number of large packs and the number of small packs. But this problem didn't ask me to solve the system, they simply asked me to write the system of equations, and so for now, I'll stop here. In our second example, Savannah and her children went into a grocery store. She bought $22 worth of peaches and mangoes. Each peach costs $1.75, and each mango costs $1.50. She bought 6 more mangoes than peaches. Write a system of equations that could be used to determine the number of peaches and the number of mangoes that Savannah bought. Define the variables that you use to write the system. That's where we'll start. The variables will be what we're trying to determine. We want to determine the number of peaches and the number of mangoes that were purchased. So that is what our variables will represent: the number of peaches bought and the number of mangoes bought. We can choose any variables that we want. I like to use variables that make sense, so I'll use P to represent the number of peaches and M to represent the number of mangoes. But of course, you could choose any variables that you desire. Now we have to begin putting the information together. Savannah bought $22 worth of peaches and mangoes. So the total amount of money she spent is $22. Now let's collect all of the information related to money. Each peach costs $1.75, and each mango costs $1.50. So the peaches are $1.75 each, and the mangoes are $1.50 each. How much money did she spend on peaches? Well, she spent $1.75 each. So $1.75 times the number of peaches that she bought will give me the amount of money she spent on peaches. $1.50 for each mango means she spent $1.50 times however many mangoes she bought. That will give you the total amount of money she spent on the mangoes. The money from the peaches and the money from the mangoes all together adds up to $22. So 1.75p, which is the money she spent on peaches, plus $1.50 times m, which is the money she spent on mangoes, equals $22. I now have my first equation. The next piece of information we have is a little more tricky. It says she bought 6 more mangoes than peaches. So let's work through that. Now, how do we write that equation? Well, let's think about this for a moment. And let's make a table where we have one column for the number of mangoes and one column for the number of peaches. If she bought no peaches at all, well, she bought 6 more mangoes than she did peaches, so she must have bought 0 plus 6, which means she bought 6 mangoes. If she bought 1 peach, she must have 7 mangoes, because the number of mangoes is 6 more than the number of peaches. 2 peaches, 8 mangoes. P peaches, P plus 6 mangoes. The number of mangoes is the number of peaches plus 6 more. So the second equation, m, the number of mangoes, equals p, the number of peaches, plus 6 more. I've now written my system of equations, which I could solve in order to determine the number of each that she purchased. But the problem doesn't ask me to solve the system, it simply asks me for now to write the system of equations. In our next example, we have Sophie. Sophie has $4.20 worth of dimes and quarters. She has twice as many quarters as dimes. Write a system of equations that could be used to determine the number of dimes and the number of quarters that Sophie has. Define the variables that you use to write the system. Let's start by defining the variables. Please pause the video here and define the variables. When you think you have the variables defined, let's come back and check your answers. Let's compare answers. The variables represent what we're trying to determine. We're trying to determine the number of dimes and the number of quarters that Sophie has. So therefore, my variables will represent the number of dimes and the number of quarters. You could choose any variable that you want to use. I'm going to choose D for the number of dimes and Q for the number of quarters. Next, we want to write our systems of equations. The first piece of information that I see is that Sophie has $4.20 worth of dimes and quarters. This is all related to money. She has $4.20 in total. Dimes are worth 10 cents each, and quarters are worth 25 cents each, which means the amount of money she has from dimes is 10 cents times the number of dimes, and the amount of money she has from the quarters is 25 cents times the number of quarters. See if you can write an equation that represents the total amount of money in terms of the dimes and the quarters. Please pause the video here and come back when you're ready to compare your answer. The dollars from the quarters plus the dollars from the dimes equals $4.20. We had 0.25Q is the amount of money we have from quarters, plus 0.10D is the amount of money we have from the dimes, gives us a total of $4.20. That's our first equation. The second equation is related to the number of quarters and dimes that she has. She has twice as many quarters as dimes. Please pause the video here and see if you can write an equation to represent this sentence. Let's compare answers. If we think about the number of quarters and the number of dimes, she has twice as many quarters as she has dimes. In other words, the number of quarters is 2 times the number of dimes. If she has 0 dimes, she has 0 quarters. 1 dime, 2 quarters. 3 dimes, 6 quarters. 4 dimes, 8 quarters. The quarters is the number of dimes times 2. So if we have d dimes, we have 2d quarters. So the number of quarters equals 2 times d. We now have a system of equations that we could solve in order to determine the number of dimes and the number of quarters that Sophie has. But the problem doesn't ask us to determine the number of dimes or quarters. It simply asks us to write the system of equations. And now you know everything you need to know in order to get started writing a system of equations in context. Remember, you can learn more about systems of equations in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.